Well, hey, Julie, thanks for meeting with me.
Hi, thanks for having me.
Well, I want everybody to know that I'm with Julie Hogan, the DPOA coordinator from CMS. I don't know if you want to talk a little bit about your bio, like
Sure.
who you are.
Yep, so my name's Julie Hogan. I am an experimental particle physicist, and I work on the CMS experiment, which is one of the experiments taking data right now at the Large Hadron Collider at CERN. And so I think I would say I've been a particle physicist since college. Like, that's when I kind of chose to do that and started working on actually CMS research. So that was in 2007. I started working on CMS research before they had even started collecting collisions. We had a big pajama party at college for the night that they were going to start the the LHC, which didn't work so well. But so I started doing particle physics research as a university student, and that really inspired me to go to graduate school. So I went to graduate school at Rice University in Houston.
Nice.
And then I've had the privilege to stay in particle physics. So I was able to get a job after I graduated with my PhD doing research. And then I was able to get a job at a university. So now I teach physics for most of my time, and I do research on CMS kind of like part-time during the year and, of course, during the summer, which is where we are right now.
That's really nice. How did you get discovered by CERN?
How did I get discovered by CERN? I don't think CERN has discovered me. I don't think they probably know who I am.
Really? No, but you ended up working at the DPOA, which is, for people who do not know, it's the data preservation and open access. Yep. So they definitely know you exist.
Okay, so that phrasing makes it sound like CERN goes out and looks around for people and says, hey, come work with us, which is not really what happens. Okay. So it's really the other way around. All right. We researchers say, I want to work with CMS. And then you actually have to put together presentations, and you have to justify to CMS why they should allow you into their collaboration. And so if you're invited into the collaboration as a university, then of course if you're a professor at a university, you can hire whatever students you want and can pay. So the experiments invite universities to participate after they've justified that they can do good work, and then leaders at the universities hire students or hire researchers or whatever to do that work. So I participated in CMS first as an undergrad student because the university group was doing CMS. Then I actually worked on a different experiment as a grad student because my university was participating on that other experiment. And then I came back to CMS because the university that hired me as a researcher was working on that experiment. So in terms of this leadership position on data preservation and open access, the way our experiment is structured is there's a lot of physics to do, but there's also a lot of operations management to do because we have to run our detector. It's too big for anybody to run on their own. And it's too big for CERN to run on its own. So CERN doesn't actually have, let's say, control over CMS. CMS has control over what we do. We make our own decisions. And of course, that's in discussion with CERN and the other experiments. But anyway, we need to all participate in running the detector. We need to all do our physics. And then we need to participate in having software and having all the things that support a group of 4,000 people, if you include the undergrad students and the engineers, being able to actually make this experiment viable. So there's plenty to go around. And as you get older in the collaboration, let's say a little bit more senior in the collaboration, there are opportunities to have leadership roles in physics groups or in software groups or in hardware groups, all sorts of different things. And so this one that I'm occupying right now is in kind of the offline computing field of CMS. And so since I was active in the group and putting on like workshops and starting to help release the open data, I was asked if I would be interested in having a higher leadership position within the group.
Nice. That's interesting. I have two questions from this section. First one is, how does CMS manage to collaborate throughout 4,000 people? And I think that's one of the things that we have been talking about recently, right?
Yeah.
Because each group, they're creating their own data frames, they're creating their own tools, they're making their own analysis. What is the process so everybody doesn't go and make something of their own? Is CERN responsible for making them all take the same direction, or the coordinators or is the operation in charge of all these procedures?
Yeah, so I would say CERN is basically, we interact with CERN in terms of getting permission to like physically come here and enter their space. That's how I interact with CERN. Like if I need a badge or I need to be able to check out a car sharing car,
right,
or whatever. So that's when I interact with CERN.
Or going to lunch,
or whatever. So I rely on CERN for like they're hosting the lab. So we interact with them when we come to the physical lab. And CERN is responsible for running the Large Hadron Collider. So CERN runs the accelerator. And the individual experiments run the detectors. So CERN management doesn't tell CMS how to do business. So within CMS, we have what we call a collaboration board. And so we elect someone to be our spokesperson. So they're like the leader of the experiment. And they have some team of like helpers, deputies. And we also elect a collaboration board chairperson. And so they are, the spokesperson is kind of ultimately responsible for the physics output and the detector operation of CMS. And the collaboration board chairperson is the leader of the bureaucracy of CMS, or the governance of CMS. And so, and they also have a team of deputies. So in that collaboration board, every university has one representative, or national lab, right? Okay, so every institute that's part of CMS has one representative in that board. And we have long meetings 5 or 6 times a year, and we vote on everything if we can't come to consensus. So part of those meetings, like the spokesperson will make a big presentation, and it will have the face of everyone who's being suggested for leadership of some smaller group. Mm-hmm. And the collaboration board has to speak up if they don't like that nomination. So we have the opportunity to kind of like vote on who's all the leadership of CMS. So underneath those big people, there are lower level leaders, and we use a level system. So like level 1 are like the pretty important people, like the coordinators of the physics plan, or the coordinators of our data management, or the coordinators of the triggers, or whatever. So we have like level 1 coordinators. And then we have level 2 people, which I'm actually a level 2. So Kathy and I are level 2s for data preservation. So we have level 2 people who, like, one example would be that you could be the level 2 leader of people who are doing top quark physics. Or you could be the level 2 leader of people who are doing Higgs boson physics.
Okay. Or
the level 2 leader of people who are working on jets. So there are all of those groups. And so if you're like, I'm a graduate student, I just started graduate school at this university and my group is in CMS, along with your supervisor, you're going to identify like, which group are you going to do some detector work in? Which group are you going to do some physics analysis in? And then you're expected to be an active part of that group. Go to meetings, talk to people, read the emails, all of these things, so that you are doing your work kind of in the context of that group. So everybody kind of knows who people are in that small group and what you're working on.
Okay, that's interesting, because I suppose that's how CERN is sustainable, because CERN doesn't have to pay all the people that are working on CERN.
No.
CERN, what it has to do is it has to concentrate that the operations working within the lower levels, that the spokesperson or all these administrative people or group leaders have actually contribute to the experiment, and they're contributing to the experiment throughout the pay of the institutions that are affiliated to CERN.
Yep.
And what do the institutions gain? Do they gain some sort of I'm part of CERN, and that's it, or what other?
Well, usually let's take a university group as an example.
Okay.
So a university will usually they hire professors, and those professors are expected to do research because that amplifies the profile of the university. So that's the type of thing you're mentioning. Like, we get to say we're affiliated with a CERN experiment. So it lifts the profile of your university, which attracts donors, attracts students, all those good things.
Okay.
And so also, in order to fund their own work, because usually professors, maybe this is different in many places of the world, but my context is United States. So in the United States, professors are usually not paid by their university during the summer.
Oh,
because we don't teach during the summer.
Right.
So if you would like to get paid during the summer, you're encouraged to find external funding for your research. And so external funding for research can pay for graduate students, pay for postdoctoral researchers to work with you, pay for an engineer to work with you, whatever you need to do your research, all your equipment. And so when you get that external funding, part of it goes to the university.
But this external funding, where does it come from? From private
Usually
sector,
from
donations,
there are
foundations?
a whole bunch of different types. Usually in particle physics, it's coming from the various governments of the country that you're in.
What about, in my case, I study in Ecuador.
Okay.
And, EPN or EPN, it's the university where I study in. It's a public university, so all the funding comes from the government itself. That pays for teachers, that pays for researchers, that pays for the research project itself.
Okay.
But obviously it has a limited amount of money.
Right.
So I suppose that it would work similar to a private university. So the private university obviously has the tuition fees from the students that pays for all these other things, but that's not enough to actually pay for extra research that the researcher wants to do in the summer. So what would you encourage colleges all around the world to do in order to find research for particle physics if they want to research in CMS, but the governments from the country where this institution lives in doesn't have the interest to support that?
Okay. So one thing that everyone can do, if you find that to be the situation of your country, is try to, as a private citizen, you can engage in lobbying, right? You can engage in trying to inform your government. Especially if you're in a democratic government, many governments are different, but let's use democratic government as a context. If you have some members of your government who are supposed to represent you, like from your area or your town or county or whatever, your region, you can contact them, you can talk to them, you can send them a letter, there are lots of ways that just everyone who's involved with science can try to make their government aware of the benefits of communally funding basic science research. Because that's usually the problem, is a lot of people, especially governments in countries that are less resourced, they have to make hard decisions about what they spend their money on. And so certainly that's true of every government, and those with fewer resources have a harder time. But one thing we do in the United States is we, organize ourselves among particle physicists to send a group of people to Washington, D.C. every year to go and visit everybody's congressperson, all the senators' offices, as many people as will make an appointment with them. They go and talk to them, and they prepare a little pamphlet to say, here's what we're doing. This is why our research is important. This is why your funding support for providing this funding in the government's budget is so important. And a lot of people don't see that because they're like, the government should use my money to solve the energy crisis, or the government should use my money to defend me,
or solve world hunger. Or
right, exactly. And so that's all true. That's all true.
Of course.
However, if that's all your government does, it's a little bit short-sighted, because big companies find this to be true as well, right? Big companies that have lots of resources will have like their actual like product departments that are like making things that make them money, or providing services that make them money. But then they have research and development groups
and the risk funding
who are trying to like look out in the future, and what they're working on is not profitable today. And it might not work at all. The project might fail. But big companies can absorb the cost of that because they have so many resources. Most companies can't and don't. So like the best example, the classic example, is that what was developed at CERN in the early 90s, the www protocol that we all use on the internet.
Right.
So who's going to, like, if we don't have funding for really basic science, how are we going to know what's possible in the future? You know what I mean? Like, it's not really feasible for private companies to like fund all of this, because it's not, it's a little too big to be profitable for them. So it makes the most sense for governments to do that, because it's in the best interest of their people, even though it's not maybe in the immediate interest of their people. It's in the long-term best interest.
That I don't know how you would have put that better. That was perfect. That was definitely perfect, and that's something that I think Edgar has been working on.
That's great.
Continuously throughout the entire history of Ecuador. Because, well, shout out to Edgar.
Hi, Edgar.
Edgar Carrera, he worked a lot directly with ambassadors here in Switzerland. He worked directly with directors here at CERN. He worked with directors in the government of Ecuador. And it's through this bureaucratic procedure that he showed them the importance of, well, perhaps not now being an affiliate state, because you kind of have to contribute a lot to be an affiliate state, but at least to have affiliate institutions from that can contribute to CERN.
Yep.
And it's thanks to those contributions that somehow Edgar managed that I'm here right now at CERN. So
that's great.
So, and it's not only me, it's a bunch of other people, physicists from different universities that, well, they learn about CERN growing up. They see it in the movies, the Hadron Collider. It reminds them of time travel or whatever, or all these various different ways in which science can sort of blow up inside the imagination of a child,
For sure.
And when you say, hey, I was at CERN, people are like, whoa, so people antimatter? Are they making black holes?
I took a picture of some students in front of the building here at CERN that says antimatter factory on the side, and we showed it in a presentation at our university, and all the other students, they were like, you photoshopped that. And I'm like, no, we didn't.
It's a real place.
They really make that there. Anyway.
That's definitely something that is important.
And the hard thing is
beneficial.
that it's so slow, right? Like, it's so slow. So, like, unfortunately, no university student is going to come in and be like, I'm going to lobby for great change in my government and see it by the time I graduate. And that's probably not going to happen. But hopefully in 30 years, we look at Ecuador and we go, wow, look at, all these great contributions to science, because they have now the resources being put toward science research.
We had this amazing talk with Edgar back in Ecuador. So it was me, Edgar, and a couple of more physicists, Jose, which was here a couple of days ago. And Edgar was saying, Latin America has a lot in depth towards scientific contribution because what discovery can I say, hey, Ecuador discovered this physicist, this mathematician? What mathematician can I say, oh, he came from Brazil, he came from Uruguay? You know, we have a lot of depths when we talk about scientific contribution. So he was like, well, if you're like, what I get out of this? It's like you don't get anything because you owe, you know. So that was a way to put it.
That's
but it did.
Probably that motivates some people better than others, but so I don't know if I would phrase it as a debt, but I get where he's coming from.
Yeah, I felt it, you know. I felt it deep down into the bone, and so did a lot of people that were in the audience. And then afterwards they reached out and it's like, yeah, that really hit me, you know. How do I work? How do we work together? So so right now we're working on putting together different groups, you know, a Rihanna team, a DPOA oriented group, another group which is looking towards the philosophy behind open science. And it's really interesting because there's something in Ecuador called open science and open government, I'm sorry. So the open government, I believe, it's not only Ecuador, but different governments around the world have this. But throughout the maturing the open governments within the country, you can always update the policies that the government puts forward in open science. That means
what part of the government is open? What is that like? What does that mean?
Well, that is something that I am just getting into, and I am definitely going to make a podcast with someone who is in charge of that and can really talk everything about it. Okay. But what I have understood is that they are working on the policies that you have to do when contributing to open science, meaning if you got open data that's coming out of your university and inside your university, what sort of data is open? Well, if it's a government university, you definitely have to
make the rules.
Well, not the government has to make the rules, and that goes into I want every single teacher to show how much money they're making, so you can really see that in the website how much every single teacher inside the institution makes. I don't think that's good.
Oh, really?
Yeah, I mean,
I think that's helpful sometimes because you can, when things are open in that way, you can, if you're like coming in as an applicant to that university, you have a lot more information to make sure that like you're not being paid less than someone at your same level and of
Obviously,
your same demographics. So there are some benefits.
Of course. And then there's other benefits that right now we're trying to get our hands on, which is, so we pay this amount of money to the professors, and this amount of money goes into these research projects. And some of these research projects don't have the impact that we would like them to have. So what are they doing with their money? You know, I give them $15,000. What's the output? I want to know. And it's open. So I have the right to look into all your expenses. So when we're talking about these underdeveloped countries, there's a lot of corruption. And that's pretty much what always gets in the way within the science development and the progress of the country itself. So one way that we can use this open data, open government, these policies, it's with this philosophy group. It's not that we sit around talking about philosophy, which we can do, which is fun too, you know. But it's also really cool because you really look into what you do with these philosophers. It's look into the policies and what's the ethical way in which you would actually do open science. You know, are we invading too much of your privacy when we ask for this information? Are we not? You know, that's something philosophers can really contribute to this conversation with. You know, various. Propositions that they can say, but at the end of the day, the output of that is really tangible within our day-to-day lives. Yeah,
it's interesting because there's definitely kind of I guess ethics is the right word to use for it. There's definitely kind of an ethical contract between you, the scientist, and whoever's funding you, a government, let's say. So like, I certainly, everything I spend on my government grant, through the university, I have to, fill out all the forms of this is what I spent, here's my receipt, and all those things. And so, like, if the government asked my university, hey, what's Julie been spending her money on? They have a gigantic spreadsheet, and they would be able to say, here's everything she spent. So, like, at some level, that makes sense because they're providing the money, and so I have kind of a responsibility to be able to tell them what I used it on.
To be accountable.
So I think that's a totally rational accountability. But at the same time, certainly my funding agency has a very, places a very high bar of responsibility on itself in terms of not seeking to interfere with the process of science. So I'm certainly not allowed to, like, take a vacation to Hawaii and pay for it on my government grant. But at the same time, they're not looking over my shoulder saying, I don't think you should hire that student. I think you should hire this student instead. Or I don't think you should actually work on that particular analysis. I think you should do this analysis. I don't like the person who designed that software. We're boycotting their company, so you can't use that. You know what I mean? Like, they're not putting that level of, they're not using their funding as a way to manipulate us. And so certainly they get to pick and choose who they fund.
Of course.
And once they fund you, you're kind of saying, I will actually do the work that I proposed and not some completely different work. But they don't exercise any manipulation. So it works. In that sense, it works well, but I could see how, like, if you were worried that if you were open with what you were doing, that someone would try to influence you or manipulate you, that would be a bad thing. Happily, in the context that I do research in, that's really not been something I've encountered.
Okay, well, that's actually really good. And in the research that I have encountered, it's also been not that way.
Super.
But because in the research that I've worked in, I had no funding, So I have to really look into how this whole process is being carried out. Right now in my university, I am part of the Council of Research.
Okay.
Entailment and innovation. Okay. So I am in charge of going through all the projects proposed within my university, look at the budget they're requesting, and either approve it or not.
Do they always have a student on that council?
This is the first time a student has been elected, because it's not like I'm like, hey, I want to be in the council, and he's like, yeah, you're my buddy, come in.
Right, yeah, no, I imagine that's something you have to
I have to go around with flyers like, hey, this is what I'm going to do. You got to vote for me.
Right, okay.
And, well, the elections were at the beginning of this year.
Okay.
And, well, since I had my CERN background, they're like, yeah, I trust this guy will actually contribute in my benefit, because the person who was on the other...
Right, you're kind of for student research. Yeah, that's your platform.
Exactly, yeah. So that my CV have definitely contributed to that. So there I saw that there was not a lot of money and too many projects. Yeah. So this is actually a really good question for you.
Okay.
Would you like a little bit of money for a lot of projects, or big money for really good projects that, are promising?
Yeah, I think the answer is always that you have to have a mixture of both.
Okay,
because you can't, and so I know for sure. I've been part of some like review panels for my funding agency, where what they do is they get a group of proposals like first that come in a certain year to a certain call, and they build up a panel of people to review them. So there'd be like 20 people, all physicists or all some scientific discipline that's close to the thing you're reviewing, and we prepare comments about them, and we can literally like kind of sit there together and, well, let's move this one further toward the yes, and let's move this one further toward the no. Mm-hmm. And so what the funding agency does is they take our input on that, and they facilitate us build as kind of experts building up this kind of ranking from really strong project to not so strong project. And then they take, we don't talk about the money in that unless it's like something really egregiously weird with the budget. But their job as the program manager is to take our ranking and figure out how they can maximize their budget amongst that.
So they got people that optimize.
Have to have some, certainly like all of our, in the United States context, our funding agencies recognize we really need to support the big projects like CERN, like the Large Hadron Collider experiments.
Priority,
so they're,
high priority.
We have to support things like that are really broad and engage a lot of researchers. But we also need small time projects. So we need physicists who just have a lab at their university and go make some lasers, zoom around the table in it, and learn things about quantum computing or whatever.
Yeah.
So they try to make a mixture of large projects with probably a broad reach and probably a very high impact, and small projects where, maybe the output will be a little bit less in like number of papers or something like that, if you compare.
Makes sense.
So a mixture is, I think, always appropriate.
Nice. I think I got some ideas that I can take back from this. Mostly because one of the things that we're looking forward a lot is, well, out of all the projects that we've had in the past, study them. And, well, these are all the projects that we have now. So given like an analysis of recent contributions and the level of contributions each of the projects has towards the world, see which ones of the projects are currently more promising. And, not only support them with maybe the personnel that they might need, but support them with the entailment that these projects need with the industry, because obviously the output of these don't just stay in papers. They have to be linked somehow within the ongoing happenings of the world.
Okay.
So let's find out where this is impacting and then map them together.
See, that's a really interesting perspective, because I would actually say I feel a little bit uncomfortable with that being like the driver, because that's like particle physics doesn't fit that.
Right.
If that was the metric, I would never fund particle physics research.
Okay, what about
because
CERN
it's not
was,
connected to any industry.
What if, well, maybe not in industry, but what if, and think about it more in an underdeveloped country.
Okay.
What if you had your physics lab?
Yeah.
That you're researching lasers.
Okay.
Okay.
Sure.
Okay. So it's not that really, complex particle physics or anything. You're researching lasers, but maybe when I talk about industry, we're not talking about companies. Maybe we're talking about CERN. And it's like, okay, so let's see what your outputs are. Let's see if your outputs match maybe ongoing research here at CERN, and let's match that. So you're not anymore...
Well, sure. I guess you have to define what you mean by industry. I've always assumed that word to mean like corporations that are active in the local area.
Okay.
Doing, so for instance, when I say industry in my school, we mean Medtronic, who's a medical technologies company, or Boston Scientific, or if you're in Silicon Valley, you mean Google, or you mean Amazon,
Maybe institution, not industry.
Okay.
Is institution a more proper term?
Sure. But anyway, I guess every group who's in charge of money to give out to research has to decide what their mission and values are. Is your mission and value to provide a broad scope of opportunities for training for your students? Is your mission and value to have more of your professors interacting with external institutions?
Yep.
Is your mission and value to have more of, to attract donations from these external institutions because you're supporting them directly, or whatever. So I would hope, this is maybe just my ethos of what a university should be. For me, it makes the most sense for the university. It seems the most right for a university, if it's making choices with the money that's been entrusted to it, to support the broadest scope of research opportunities that can benefit their students.
Right, because the students become
so
the
in that
researchers
case,
sooner or later.
in that case, I would maybe not pay so much attention to what are the outside forces that are trying to stick their fingers in what I choose. CERN, med tech company down the road, whatever. Big energy conglomerate in my country. I would maybe pay less attention to that and more attention to, like, have any of my departments been really stagnating for funding? Have any departments been getting an overly large portion of the funding, and things like that. But everybody has to decide what their mission is, and then you just try to make the money fit the mission.
It's only what it's great whenever a bureaucracy isn't, within these procedures of mapping out. Okay, so I have 3 departments, and one department's getting 90% of the money, but it's getting 90% of the money because he gets along with the head of the department gets along with someone. That's so how do you tackle that? You can't really tackle that. So maybe it's somewhere. It's a place where you can't really put your hands in because you'd really need.
Who are you? Are you the undergraduate student, or are you the council of people overseeing all distribution of research funds? Because I would think that the council of people overseeing the distribution of research funds doesn't care about the personal relationship between someone and the head of their department.
So it is important whenever tackling a problem to not go as you, but as you.
Right, yeah. So you're right. I can imagine how you don't feel like you have agency to solve that problem.
Of course.
That's probably reasonable and fair. So for you, I would escalate that maybe to
the council.
Like, I feel like I'm observing something that's unethical.
Right.
It's hard to say those things. It's not comfortable and not easy, but you can.
And you have to.
I think you should, yeah.
And you have to.
I certainly think you should.
If you want to sleep at night. All right, let's see how much time we got. We still got some time.
Yeah, maybe 10 minutes.
Yep. So, that's just a little insight of, pretty much some direction that I think would be good not only for my institution, but any really institution that maybe is going through any one of these problems. All right. I think we talked about a little bit of your involvement in CERN, a little bit about education itself, in a research level. Now, I would like to know a little bit about your experience as an educator with students, what do you think? Well, I obviously know that you think that being an educator is important, but what are the steps to being a great educator? Because a great educator is someone who's always continuously learning as well. And with this era of AI, a lot of educators are very intimidated with the capacities of machine learning and all these new artificial intelligences that can sooner or later replace teachers. I think that'd be a really nice topic.
That's actually not something that any of my colleagues and I have discussed as a fear. That's interesting for you to bring up.
Okay.
It hadn't occurred to me to be worried about them replacing teachers.
Really?
They're wrong so often. I certainly hope they don't replace teachers. We've way more focused on worrying that the students will use them as a way to not learn anything.
Okay.
But anyway,
so AI is on your side. So,
we're okay. So most of our experience of it, I'll just give a story. I teach a class on career development, and my students have to write a personal statement, if they're going to apply for grad school, right? Okay, so that's one of their assignments is write this. It's not a long paper. It's a 1.5 pages, maybe. Just write it. Just tell me about your experiences and your skills and your goals for the future. You don't need to ask ChatGPT what your goals are for the future. And if you ask ChatGPT to write a paragraph about how your goal is to be an electrical engineer, it's going to come up with this flowy gunk where I was literally reading a student's paper, and one paragraph, I got to the end of the paragraph and I was like, this said nothing. It had like 6 sentences that had like 14 adjectives each that are super flowery, and there's absolutely no content. And it's all very well structured, very long sentences, very complex, but it had no meaning. And then the next paragraph sounded like a very young student had written it. And that was the paragraph about how he actually spent last summer working for Bob, his uncle, or whatever. And then he went back to ChatGPT for the last paragraph about how this was going to change it. You know, his skills were perfect to change the world. And I'm like, did you what was the thought process there? Did you think that I was so stupid that I wouldn't know that? Anyway, so we've mostly experienced the AIs being unhelpful. I haven't really so far discovered a way that they like make my life much easier or are really like changing the game in terms of upping our learning potential. I'm not seeing it yet, and that's hopefully going to change in the future. But yeah.
that is.
I Google something now and I get the AI.
thought.
I get the little AI response when I Google things, and my immediate assumption is that it's probably incorrect. And then I go click on the websites and I see, oh, it pulled this sentence from this website and this sentence from this website and this sentence from this website, and they don't have anything to do with each other. Like, it's just glommed together something that seems like maybe it has some probability of being right, but is it? Probably not. Anyway,
how does that?
I'm a little cynical about the AIs.
I think that's a fair. That's totally fair. I can't go against.
Yeah. And that's
anything.
probably specifically to language AIs, as opposed to like what we use in science more, which was like numerical AI.
Of course,
numerical AI I have a little more understanding and faith in than language AI, because language AI has a really different purpose, which is like to convey information to people that they're going to like make their life choices off of. And even if it's tiny life choices, like whatever you're Google searching for today, but that's like a different level of responsibility on the AI side than me like being like, what's the probability of this event being a Higgs boson or being not a Higgs boson? If I'm wrong, I can just quantify the amount of wrongness and it's fine. That's a numerical. Anyway,
I love your approach on it, because your approach goes into that the information which the language AI is trained on is so sparse. It's so much, and it's extracting information from everywhere.
Yeah.
And within the language AIs, what they usually do is that, well, they sort of emulate the thought process for the answer, and that's why they can structure the answers so well. Right? But if they're structuring the thought process from a whole huge data set, then there's no real thought process in it, you know?
Yeah.
It's pretty much, well, you said this, and for this other part, I'm going to ask what he says, and then what you have, it's a collective answer. Sure, it's a politically correct answer. You also have to create some bias into the answers, because you can't have a racist AI.
The most useful I've found the language AIs is when it's like, I need to write like a blurb for something. Like I need to write a paragraph for my website to make this project I'm doing sound attractive. So I can ask the language AI to write me a paragraph about this, see what it comes up with, but then I have the critical facility to be like, oh no, that's wrong.
So going back to education.
Anyway, education.
I think it's perfect, because having that critical, maybe teaching how to be critical is one of the pivots endpoints of actually making students useful within their usage of large language models.
Yeah.
Because I myself, well, yeah, of course, I've used AI for a homework or anything. I hope my university doesn't sue me if they if they put this on court or something. But it does save me some time.
Sure.
You know.
Sure.
So let's say I have 8 assignments, and 3 of these assignments are making these paragraphs. About my life choices, and I'm like, okay. Maybe
You can use it as a first stepping point.
yeah.
Yeah.
Or I'm like, okay, right now I kind of know my life choices, and I know this teacher really doesn't care about what I do with my life. So ChatGPT for this and task, while I'm doing a task that actually contributes to my goals. So if I can justify the way, if I can sort of defend the honor of the usage of GPT in homeworks.
Professors love nothing more than to realize that the student feels that you're, completely useless to their educational development.
Yeah,
That's our favorite thing.
Well,
I'm being sarcastic.
No, I know. I know.
But anyway,
that was the fear.
You were talking about like critical thinking, and that's so important and really hard to teach. So like one of the things that I was realizing, one of the things I did like as a little test to my students was one class I was teaching, I gave, 2 midterm tests. And I repeated questions from those midterm tests on the final verbatim to see which students would actually take the tactic of saying, I made a mistake in the midterm test. Let me use that as a study tool to improve for the future.
0%?
Very low, tens only of percent. And we also allowed them to like bring a note card, right? Like a little reference to the exam. And so I, of course, didn't ask them to literally repeat something that was like derived in their textbook. That's not a good test. I made like some small changes and said, apply this method you learned to this new situation that's like tiny bit different. And most of the class wrote down exactly the thing from the textbook that they had written on their note card. And so I was like almost in tears at the evidence of just complete lack of any critical thinking. And they obviously assumed that what they would be judged on was their ability to like copy from the textbook onto their card and then from their card onto the paper. And so I set up, so now in my classes, what I've started doing is I've started giving problems where like the information's not all there. Like you need to look that up on Google. You need to look that up in your book. You need to go and Google, how do you calculate this thing? And they get really stressed and confused for the first part of the semester because they're like, we can't solve this problem. We don't have enough information. And the thought process of how could I get the information that I am missing? It takes months for that to even start happening. Most of the students realize they don't have enough information and they just shut down and they raise their hand and they say, I don't have enough information. What do you expect me to do? and it's like, I get that. And so I basically look at them and say, I expect you to think about it. What are you going to do? Where could you find that?
I think that's amazing. I think to do that, well, first of all, you have to be a critical thinker to teach critical thinking.
Yeah.
So, then we'd have to ensure that all the educators have critical thinking.
That's hopefully
if that's what
I would certainly hope that that's evidence of some ability to think critically is hopefully on the hiring goals of most universities.
Yeah. Well, I'd hope so. And once you have that, I think a genius way to do that is starting out with a problem that they won't be able to solve. You for sure know that you won't be able to solve day one, but throughout the semester or throughout the time period in which you're with the students, you'll always go back to that question and be like, okay, well, at the end of the week, let's go back to the question that I expect each one of you to answer differently by the end of the course.
Yeah.
And throughout the semester, like give them tools in which they would slowly put together different parts of knowledge that start interconnecting in ways that will bring them to the solution or a possible solution, because that's what you're doing at university. You're learning to think. You're learning to write.
Yeah.
You're
Well,
learning
and unfortunately,
to structure.
that's a philosophy of education that what we're seeing from like surveys is that fewer and fewer students buy into that. More and more students have the educational philosophy that they're paying money for a credential.
Yep.
And so they're paying money to get a credential that will get them a job. And
That will
so
get
they're
them
not
money.
actually interested in learning how to learn, which seems really short-sighted to me, because surely you're going to get fired pretty quickly from
Yep.
the job you got with your
Of
awesome
course.
credential if you
course.
can't figure anything out.
Yep.
But it's really hard to quantify that, like, being a smart person who can think about stuff and solve problems is more important than having a piece of paper that says Bachelor of Science.
Well, write that on a rock.
There we go.
Write that on stone.
There we go.
I think this has been a really great interview.
Yeah, it was fun.
I loved every single part of it, every single edge or angle that we explored this whole thing, because it was pretty much connected.
Yeah, there we go.
Articulate. I hope to be back here soon, and I hope to see you soon. I hope everything
Awesome.
goes great with you.
Thanks.
Thank